not too bad. $9,000, but you can do this course for free. You don't have to pay anything. What? Oh, pounds, sorry. Right. GP, pounds, okay. And, okay. Okay, so that's the school. And the course, again, is Mathematics for Machine Learning. Okay, Multivariate Calculus. So we've been studying calculus, but we've been studying calculus with just x as the input. The idea is to go beyond just one input and expand it so that we can work with many variables. Okay, so it's taught by this guy, and this guy, and this guy. Usually they're always guys, not always, but often. So I want to do the first, so you can, make sure, just like the last time, you don't pay for it, unless you want to. So the other one I wouldn't have recommended it. There would be no reason to pay for it. This one you could pay for it if you wanted to get a certificate. It would be worthwhile putting on your resume or your CV or whatever you have. So it wouldn't be bad to have that on your CV. So you could consider paying for it, but it's completely up to you. So anyway, let's look at the syllabus. So I want you to do week 1, which is actually just a review of what we've already done. So because it's just calculus, just single variable calculus. So if we look at it, they go through let's see, the first video is Welcome to Module 1. Second video is about functions. Third video is about rise over run, which means slope. Is definition of derivative is the next video. Differentiation, product rule, chain rule, something else, and that's it. Okay? So that will be for next week, and we'll again have a quiz, but as you can see, I'm not sure, let's see, when he goes into the definition of a derivative, I have to go to the course. Okay, so let's see, videos. Well, here. Okay, so when he goes to definition of the derivative, where is it? Where is it? Back to week 1. Let's see what kind of detail they give for this.
Now that we've explored the relationship between functions and their gradient, we should be ready to lay out the
now he's using the word gradient. Okay, so that's an important word in machine learning, but it just basically means derivative. But it can be applied for multi-variables.
Formal definition of a derivative. All we're going to do is translate the understanding about gradients that we saw in the previous video into some mathematical notation that we can write down. Unfortunately, this is the bit that a lot of people seem to find uncomfortable, so I will do my best to make it as painless as possible. We talked in the last video about horizontal lines having a gradient of 0, whilst upwards and downwards sloping lines having positive or negative gradients respectively.
So
we can write down a definition.
Looks like he's using the word gradient as slope, actually. Okay.
In this concept by taking the example of a linear function which has the same gradient everywhere. So if we start by picking any 2 points, let's say here and here, we can then say that the gradient of this line is equal to the amount of that function that increases in this interval, divided by the length of the interval that we're considering.
Okay, does everybody know what he's talking about? Right, we're talking about the slope, that's all. Right, he's just using another word for slope. But he's trying to break into the definition, which is up here. So we did that a I just wrote that on the board, but the only difference is that here he has delta x, and I've used h. It's the same thing. You can call it delta x, or you can call it h. Okay, so this is the same thing. So he's breaking into the definition. So this is going to be pretty much a review, maybe a little bit different language, but basically review. Okay? But I want you to do that because then the next week we're going to go to, where is this?
Now that we've explored the relationship between functions and their...
We're going to go to, where is it now? Subtitles. How do we get to the next one? Can't seem to get out of lesson 1. Okay, well anyway, next week we should be able to see lesson 1, and I'm saying week 2, pardon me. Next week we should be able to see week 2. Yeah. Yeah. No, don't get tricked into that. Okay, watch, I'll do it again. I just did it now. Let me do it again for you. By the way, let me just see what else is here. So week 2, let me just, before I show you that, let me just show you week 2. So week 2, we do partial differentiation, so, and something called the Jacobian. Okay, so it gets advanced quickly. Okay, so that will be good. All right, so you really jump right into kind of the advanced math that you need to do data science. Okay, so anyway, let me show you how to register without paying. So I'll do it through the incognito window, and I'll go to the site. And you go either log in, or I have to sign up because I'm in the incognito window. I'll join. Okay, now. So here it says, try for free, and it has enroll, right? So I'll click on that, and I try to do this, but that right here is audit. Okay, so you definitely don't have to pay. Somehow you have to navigate, even if it shows you something else, you don't have to pay. Okay, and then you can start. All right, so you don't have to pay. All right, any questions about this? So for next week, you should go through that. Okay, and so we have about 9 minutes to start on integrals.
So the word integral, we have a couple different words. So true integral.
Okay, so there's a word called integral, and there's also another word called antiderivative. And basically, these are the same. Well, we'll see that they're kind of different, but basically they're the same. So we have these two different words. So the word antiderivative is suggestive of something, right? As opposed to integral, it doesn't mean anything. So antiderivative. So let's suppose we start with x to the 4th, and I ask you what's the derivative of that? And you'll say for x to the third, right? So we write that the derivative of x to the fourth equals 4x to the third, right? Okay, so the antiderivative means, if I ask you what's the antiderivative of this, it's this. So it's just going backwards. Okay, so if the derivative of this is that, then the antiderivative of this is this. Okay? So that's what the antiderivative means. So how do we figure out, suppose we start with this, how do we figure out the antiderivative? So it's a little bit, to sort of think backwards, right? So if I say, what's the antiderivative? Antiderivative of 4x cubed. So what's the answer? Well, we just did it. So it's x to the fourth, right? Okay, but what if I asked you what's the antiderivative of 10x to the 11th? So we didn't just do that one, so you still have to think about it. So what's the antiderivative of 10x to the 10x to the 9th? All right. What's the antiderivative of that? X to the 10th, right? Right, because we start with x to the 10th, derivative, you get this, right? Okay? So if I ask you what's the antiderivative of that, what's the answer? X to the 9th, right? Because the derivative of x to the 9th is 9x to the 8th, right? Okay, but then suppose I ask you what's the antiderivative of that? That's, we just lowered everything by a factor of 9. So probably the antiderivative will be reduced by a factor of 9. So before the antiderivative was x to the 9th, so now it's probably this. Right, so what's the derivative of this? 9x to the 8th over 9, which is that. Okay? Get it? So what's the rule what's this, like the power rule? So if I start with x to the 9th, the antiderivative is, is what? Yeah, so it's x to the 8th over 9x over 9, right? Is that right? No, sorry. What am I doing? Sorry. It's x to the 10th over 10. Is that right? If I take the derivative of this, do I get this? 10x to the 9th over 10. Yeah. Okay, so what's the rule? So what did I do? I raised this by 1 and then divided by this. Right? So if I want to know what's the antiderivative of x to the n, it's raise it by 1 and divide that by that. Right? So what's the derivative of this? Am I doing this wrong? I know, it's right. Right? What's the derivative of this? N plus 1 x to the n over n plus 1, which is x to the n. Right? Okay. So that if we want to go antiderivative, this is the power rule. Okay? Does this make sense? Okay, do you understand what the antiderivative is? Okay, now we could make up, we could say a antiderivative, maybe that's the symbol for antiderivative. So we could say the antiderivative of x to the n is what? Okay, that we could make this our symbol for antiderivative. Okay? Is that clear? So how about let's just do one more. If I ask you, what's the antiderivative of x to the 100? That's equal to, what is it? X to the 101 over 101. Is it true? Take the derivative of this, what do you get? 101 x to the 100 over 101. That's what you get, right? Okay? However, that's not the notation for antiderivative. The notation comes from a long time ago, and it doesn't look like that. Okay? But we could make up our own notation, but we have to be able to read the conventional notation as well. So unfortunately, it looks very strange. Okay, but does everyone understand the rule? Okay, so the notation is very weird. Okay, it looks like this. Okay, but it still means the same thing. So what is the answer to this? The same thing. What is it? Okay, so the notation for antiderivative is this. All right? So you don't have to think of it as anything but notation or antiderivative. Now obviously it seems to have some other kind of meaning to it, but mathematically speaking, one meaning of it is just notation. Okay? So if I ask you, what's this? What's the answer? What? X to the 11 over 11. Right? Okay, now suppose I added a 10 to this. Would this still be true? That is, if I take the derivative of this, do I still get the... Well, the derivative of this part is this, right? And the derivative of 10 is 0, so it's still true, right? So it's still true. So the answer, we could do that. And obviously we could do that. Right? And obviously you could do that. Okay? So really we should say that it's this plus a constant c. Okay? Because when we take the derivative of c, it's just 0. Okay? So that's a better statement of what the antiderivative is for this. Okay, so by the way, we could write it like this, right? Okay? Okay, so that is the first meaning of integral is that. So we don't have to use the word antiderivative. We can say the integral of this is this. You can say that the integral of x to the 100 is this minus whatever constant you want to put in there, including 0. Okay? So that's called the integral or the antiderivative. Okay? Now, the symbol suggests that it must have some other meaning as well as that, as well as this meaning, right? Otherwise, we would come up with this ridiculous looking symbol. Right? This looks like an S. It's actually kind of like an exaggerated S. So there's meaning to that also. So there's an alternative understanding of what the antiderivative or the integral is. Okay, so we'll come back to that next time. Okay, but don't forget that you have this Coursera course to do for next time. Okay?